G'day everybody. Today I'm here to teach you some hot air balloon chemistry. So it's not too complex stuff because hot air balloons were first flown over 230 years ago, so they were the first flying machines to carry people. So if they can figure it out 230 years ago, then we can figure it out now. So there's one main principle, which is that hot air rises basically. So right here, I'm going to set up a simple apparatus to show you what happens to air when we heat it up. So do you want to come a bit closer so that they can see exactly what's going on? So I'm just putting the balloon on the flask here. So basically what happens when I put the balloon on the flask is now all of the air that's in there is sealed in, it can't escape. So when I get this heat gun here and heat the air in the flask up, just notice what happens to the balloon. Alright, might take a while. The air molecules are slowly getting hotter and hotter. That means that they're moving faster and faster. And the faster they move, the more they bounce off each other. And the more they bounce off each other, the more energy that they have. And you can see that the balloon's wanting to come out now because the molecules are bouncing off it more and more. It's slowly popping out. So basically, the air on the inside, because I'm heating it, it's expanding. So what does that mean, that the air's expanding? Well, now the same volume of air is going to weigh less. So that's the concept behind why hot air rises. And now you can see that it's expanded enough to pop the balloon out all the way from the inside. Okay? So, now why does air do that? Well, when you have a balloon full of air, it's pushing back on you. So when I push down on the balloon, the reason why it doesn't just cave in is because the air is always pushing out. The molecules are always bouncing out against me. And the speed at which they're bouncing is dependent on their temperature. So the next experiment that we're going to do shows how this works for an actual hot air balloon. Okay, so we're back for the second part of the experiment with Mr. Trollface balloon here. Now this is my model hot air balloon. Okay? So it behaves pretty much like a hot air balloon does. Now, I've got it weighed down by a little pendulum here so that it doesn't raise up too far, but the gas that's in here is lighter than normal air, just like hot air is lighter than normal temperature air. So what happens is when I let go of it, it rises just like a hot air balloon rises with the hot air. Now, what happens when they want to bring a hot air balloon back down to the ground? Well, if you've got all the hot air in there, you're just going to keep rising. So you don't want to go all the way up into space and then blow up. So basically what they have to do is slowly cool down the air. Now, if you want to get down a lot quicker, then you could cool the air down a lot quicker and you would see that effect. So, what I've got down here is liquid nitrogen, which is negative 200 degrees Celsius. So, my helper here, Kim, what do you think is going to happen based on what we've learned so far from the other experiment? What do you think might happen when I pour the liquid nitrogen on top of the balloon?
The balloon will shrink?
Yeah, exactly. So if hot air expands, right, then it makes sense that cold air is going to make the molecules travel slower and they're going to shrink. So what do you think might happen because it shrinks?
It will sink down to the ground?
Yeah, exactly. And then we'll see the opposite when we let it cool. When we let it warm back up to room temperature. Alright, so this is what we think is going to happen. Now let's test and see if it's actually what happens. So, I'll just need to hold him down here for a second. He does want to fly away, but alright. So, actually, let's rise him up a little bit, just so we can see. So, you can see he's dropping down to the ground as he gets cool. Now, I'll put him over into the bath and we'll make him really cold. So, do you want to come up closer and just show exactly what's happening? Poor Mr. Trollface there. He's shrunken down a lot. Now, he's just going to want to sit on the ground there. Now that he's out of the liquid nitrogen and he's gradually warming back to room temperature, he's going to slowly rise up as he expands. So it may look like he's come back the whole way, but he's still got a little bit of room to expand now. Alright, don't go running anywhere. Now if we want to speed this up, then I could just get my heat gun from before and just give him a A little bit of a push. That should be enough. Now you can see, runaway balloon, he's gradually coming up. Make sure he doesn't get sucked into the fume hood. So, whoops. He's getting sucked into the fume hood. Put it down. So, well, he hasn't quite got the energy to make it up to the top yet. Let's see if we can heat him up a little bit more. Make him expand so that he can get all the way up to the top. Just like how we heat a hot air balloon to get it up there. Okay, now let's see if he rises when we let him go. There we go. So, as you can see, that's how a hot air balloon works.